Good morning, students. So, continue same lesson, 11th one, Introduction to Trigonometry. Then yesterday I completed 11.3, all 7 questions. So, before going to start to next exercise questions, again you have some proof, identities. So, next topic, very important stage in this lesson, that is trigonometric identities. Trigonometric identities. We have mainly three important trigonometric identities. Please note down. First one, prove that sine square theta. First one, sine square theta or sine square a plus cos square a is equal to 1. So first identity, sine square a plus cos square a is equal to 1, or sine square theta plus cos square theta is equal to 1, whatever it may be. So a means acute angle. So sine square 50 degree plus cos square 50 degree. So both sides a value same. So here 50 degree means here also 50 degree. Sine square 50 degree plus cos square 50 degree. Sine square 35 degrees plus cos square 35 degree. The value of this one is equal to 1. Next, proof. Yes, consider right angle triangle. Very simple proof. Write as ABC. At point B, there is a right angle. Yes. Now, apply Pythagoras theorem for this right angle triangle ABC. Square on the hypotenuse is equal to sum of the squares on the remaining two sides. So, AC square is equal to AB square plus BC square. In bracket you write Pythagoras theorem. Now, first one just to observe here, sine square. What is the ratio of sine? Opposite divided by hypotenuse. So 1. Here 1 means, so is equal to, so AB, consider A is acute here. So consider A is acute. So this is called as opposite side. So this one hypotenuse. So this one base or adjacent. Now you have to convert this equation in the form of sine square a plus cos square a is equal to 1. So RHS part is equal to 1 means, so here RHS AC square, so divide by AC square on both sides. On both sides. Yes. First I will write LHS part, this one. So AB square divided by AC square plus BC square by AC square. So next AC square by AC square. So this implies, next, according to this figure, right? AB means what here? AB means base. Yes, base. AC means hypotenuse. So base by hypotenuse is the ratio of cos plus base. So BC here, BC means opposite. AC hypotenuse whole square is equal to AC square gets cancels as 1. Now, which implies, so A is acute here, according to this acute angle, right? BC by, base by hypotenuse. So base by hypotenuse is cos square, we consider A is acute, so cos squared A plus opposite by hypotenuse. So opposite by hypotenuse, that is sine square, we consider A is acute, is equal to 1. Therefore, yes, right, according to the given question, sine square A plus cos square A is equal to 1. So this is the very important square relations are identities. As first one, sin square A plus cos square A is equal to 1. Consider right angle triangle ABC. A is acute. If A is acute, the side which is opposite to A is called as opposite. Hypotenuse remaining base B is means AB is the base. Apply Pythagoras theorem. Square on the hypotenuse AC square is equal to AB square plus BC square. So just what we need here 1. So divided by AC square. So A divided by AC square on both sides. So AB square by AC square plus BC square by AC square is equal to AC square by AC square. So according to this figure, AB means base divided by hypotenuse whole square plus BC, that is opposite, divided by hypotenuse whole square. AC square gets cancelled 1. So base by hypotenuse is equal to cos square A. Opposite by hypotenuse, that is equal to sin square A, is equal to 1. A, why? Because we considered A is acute. Therefore, write in order, sin square A plus cos square A is equal to 1. Yes, this is first identity. Now, consider second identity. Prove that, second one, 1 plus tan square A is equal to secant square A. Second identity, 1 plus tan square A is equal to secant square A. Again, very simple. Earlier what we did, that is divided by AC square. Next divided by BC square. Next divided by BC square. We get 1 by 1. We have one more identity after this. Yes, first before going to start, first you see here, secant square. Secant is the reciprocal of cos. Cos means base by hypotenuse. So secant means hypotenuse. Correct? Hypotenuse divided by base. So hypotenuse means AC, base means AB. Yes, divided by, divide by, as AB square on both sides. Divide by AB square on both sides. So which implies S. So again same here. Otherwise I will write once first. AC square is equal to AB square plus BC square. In bracket Pythagoras theorem. Yes. Now we divide as AC square by AB square is equal to AB square by AB square plus BC square by AB square. As according to figure, AC means hypotenuse, AB means base, whole square is equal to AB square gets cancelled, 1 plus BC means opposite, AB means base, whole square. Yes, now from this figure or according to this figure you write hypotenuse by base. Hypotenuse by base is secant square A is equal to 1 plus opposite by base, that is tan square A. Yes, this is identity number 2. Yes, very simple. But in examination they won't ask, but next exercise questions completely depend upon the identities. Okay, next third one, prove that, third identity, note down, prove that 1 plus cosec 1 plus cot square A. Prove that 1 plus cot square A is equal to cosec square A. This is identity number 3. Third one, identity number 3. Third one is prove that 1 plus cot square A is equal to cosecant square. Again apply Pythagoras theorem. Yes, AC square is equal to AB square plus BC square, in bracket you write Pythagoras theorem. So in previous cases, first case we divided by AC square, second one AB square, then finally last one, that is remaining BC square as divide by BC square. So this implies, so AC square by BC square is equal to AB square by BC square plus BC square by BC square. So this implies AC hypotenuse as BC opposite whole square is equal to AB base by BC opposite whole square plus gets cancels 1. So which implies hypotenuse by opposite. It is the reciprocal of sine. Reciprocal of sine means that is cosec square. A is equal to base by opposite. Reciprocal of tan, that is cot. Cot square A plus 1. So this is identity number 3. This first one, sine square A plus cos square A is equal to 1. Second one, 1 plus tan square A is equal to secant square A. Third one, cosecant square A is equal to cot square A plus 1. So here are the 3 important identities. Now you make a list all 3 identities. Yes, points to remember. Or note you write. No, not points to remember. Make a note. What I proved all 3. Yes, make a list or make a note one by one. Yes, note. Yes, I will write one by one. Yes, first one, the main one identity is sine square A plus cos square A is equal to 1. You remember this one. From this, we can write sub-identities. Yes, sine square A is equal to 1 minus cos square A. Just to send this one here. Or, yes, sine A is equal to under the root 1 minus cos square A. But you must remember, this is very important. Then you can write the remaining easily. Next, again same identity. This implies cos square A can be written as this time 1 minus sine square A. Therefore, or which implies cos A can be written as 1 minus root of 1 minus sine square A. Yes, these are sub identities. So remember this one very important. Yes, by using second identities, 1 plus tan square A is equal to secant square A. Yes, from this, tan square A can be written as secant square A minus 1. As from this, again, tan A can be written as root of secant square A minus 1. Next, by using third one, just what I proved, as 1 plus cot square A is equal to cosec square A. So this implies cot square A can be written as cosecant square A minus 1. So this implies cot A is equal to under the root cosecant square A minus 1, or cosecant square minus cot square A is also equal to 1, or this implies as cosecant square A minus cot square A is equal to 1. Yes, but the main thing is you have to remember yes 1, 2 and 3 important identities. So you can write the remaining identities. Okay, yes, you must remember, don't forget. Next period I will continue problems on these identities. Okay, thank you very much.